right, so here we have a twin for a quiz y'all have. I'm not sure what day it'll be. Let's see here. Probably be either Wednesday or Thursday. Probably Thursday, looking ahead. That's kind of what I'm thinking. That Thursday right there, the first. Anyways, hopefully it goes well. I don't know. We'll find out. Convert 85 degrees into a radian. So you already have this formula. Whether you've memorized or not, I couldn't tell you. But what you do is you take your degrees, and to convert it into a pi rad, you multiply by pi over 180. And we're going to leave this one in exact form. So I'm not going to be worried too much about the pi. I'm mainly curious what 85 over 180 simplifies to. You know, you could both divide both by 5 or whatever. So it is 17/36 as a pi rad, or maybe you like the decimals, but we'll see what I do on this. 1.484 rads. I really like the perfect form, which is what this is, but you also need to be comfortable with rounded, and that's the issue with this. This is rounded, right? Anyways, convert 14 pi over 5 into a degree. There's lots of ways of doing number 2. You can fall back on a formula. To go the other way around, we multiply by 180 degrees in 1 pi rad. And what happens is the pi's cancel. But if that's too much for you, and it is for a lot of kids, and I don't know why, they don't grasp basics. You can legit just type the whole blasted thing in your calculator. I've already got some names floating through my head who'll do this, but anyways, you get 504 degrees. I wouldn't have done all that. Or, you know, and at least you're supposed to know, pi is equal to 180 degrees. So this is what I usually do. I just replace pi with 180. And then, of course, I usually do the math by hand, but nobody's asking you to do that. Nobody's asking you to do that. We should. 5 enters 180, how many times? 36 maybe? But anyways. I'm sighing here. I hate that I have to show all this stuff in a calculator. I really do hate that I have to show all this stuff. But you get 504 degrees. Either way you do it. Doesn't really matter. All right, convert 3.43 radians into a degree. This gets kids sometimes because they don't see the pi and they don't think it's the same formula. But it's done the same way we did 1. We're just going to take 3.43, and this is a radian. So what we do is we want the radians to cancel out. So the pi rad's got to be in the bottom. And up top we have to have the degrees. And then the rads cancel, right? And now we're degree. But it's the other way around. 3.43 times 180 over pi. 196.525 degrees. So there's number 3. They're not hard. 4 is draw the following angles. Make sure you show the rotation. Here's what I mean by this. Give me just a minute. Let me show you what's wrong. Somebody at the door. All right, so anyways, I was going to show you what's wrong. What's wrong is when a kid just like puts a dot. That's roughly in the right spot. Or what's wrong is when a kid just does this. That's wrong, okay? So let me talk about how a kid came up with that. Negative 410 degrees would rotate clockwise. That part's right. But it's going to rotate a full 360, so I'm going to add in 360. And then I'm going to rotate 50 more, like a clock. And that's going to be about right in there. And that's where the angle terminates. This is right. I want to see the rotation. I even have a little arrow there specifying that I rotated like that. So make sure you do it the right way. All right. 3 pi over 4. Most kids are going to convert this into a degree. That's just how they're going to do it. So they're going to say 3 times 180. Hopefully by now, because you've already had at least 3 unit circle quizzes at this point in time, that you have memorized what 3 pi over 4 is. Anyways, you go and you push some buttons and you get 135 degrees. That's 135 degrees of positive rotation. All angles start on the positive x-axis and they rotate to the terminal side. There's 90 that I'm taking care of, and there's 45 left, which is halfway through quadrant 2. Got my little arrow there. That's the right way. Okay, this is right. Wrong is just that. I want to see your rotation. Negative 15 pi over 2. Again, kind of the same thing here. We need to go ahead and convert to degrees. See what she is. Should be negative. It's big, isn't it? Should be negative 1350. But I'm pretty tired. Anyways, what I got? I got negative 15 times 180. That is sitting pretty over at 2. Negative 1350. I meant to do a regular rad here, but I forgot to. Negative 1350 degrees. Now that's going to rotate around a circle several times, at least 3 times. All right? I know that because I know what 360 times 3 is. But anyways, I can add 360 a bunch of times. What I'm doing is I'm finding what's called coterminality. We'll be left with negative 270. So what's happening here is we're rotating negatively, which is clockwise, once, twice, thrice. And then we have to go 90, 180, 270. We stop right here, okay? So we have our initial side, positive x-axis, terminal side, and the arrows are telling me the rotation that happened. All right. Find 2 angles coterminal with negative 15. That means that you add or subtract 360 degrees, because if you rotate full circle, you're right back where you start. And who knows, this will be a select all situation, so you might have to add more than once. You might have to subtract more than once. But if I just add 360, I'd be sitting at 345 degrees. Or I could plus 360 again, right? And I could be at 705. And I could just keep going like that. I could keep adding 360. Or I could take away 360 and that get me to negative 375. And I could just keep taking away 360 again if I wanted to. It's, who knows what I do. That's negative 755, I think. I know, I'm pretty tired here. 720, 35, yeah, negative 755. And I could just keep going like that over and over and over. Same deal with this one. I will say though, most kids are really going to struggle with plus or minusing 2 pi. I'm going to work through the process. 21 pi over 4 plus 2 pi. I have to convert the 2 pi into 8 pi over 4. And I would get 29 pi over 4. A lot of kids are going to struggle working with fractions because, you know, that's a 5th grade math skill, right? Or maybe I do the subtraction, 21 pi over 4 minus 2 pi. And again, I have to do the conversion, 21 pi over 4 minus 8 pi over 4. 21 minus 8, last I checked, was 13, I believe it is. 13 pi over 4. And I can keep going. I can keep adding or subtracting. Most kids, though, are going to convert to a degree and then convert back. So, again, this is most. Most kids convert into degrees. You end up doing twice as much work and then convert back to pi rads. I don't know why you waste all that time. I assume it's because you don't like fractions. That's what I'm guessing. But anyways, you know, you can go 21 pi over 4, replace pi with 180. And then you divide that by 4 because there's a 4. And from there, they do the whole plus or minus 360. So say I take away 360. Cool. I can convert that back into a pi rad by multiplying by 1 over 180 and then reinserting the pi. So it's 3.25 or, something I've already done before, 13 pi over 4. I just assume you guys do that because it's fractions. It's the only thing I can think of. All right, what do we have here? If the cosine of beta is x over 4, find the cosecant of beta. So there's a couple of things you have to know. You got to know all your sine ratios. Like you got to know that sine of some angle is opposite over hypotenuse. Cosine of some angle, and it's called beta, is going to be adjacent over hypotenuse. The tangent of beta is opposite over adjacent. And you also have to know your reciprocals. Cosecant is the reciprocal of sine, and cosecant is a hoe. Secant is the reciprocal of cosine, and it's a funny guy. And then cotangent is the reciprocal of tangent, so it's AO, it's excited. So those are things you have to know, because I might not use cosecant, cosine, and cosecant. I might use some other trig ratio. Who knows what I use? Because I don't. I could use anything. Anything is fair game. So I'm going to draw, just because it'll stimulate the neurons in my head. And I'm going to throw beta in the corner. And I know that cosine is adjacent over hypotenuse. So next to this thing is the x, and the hypotenuse is the 4. To do cosecant, I got to have hypotenuse and opposite. So I'm going to do a little Pythagorean theorem over here. I'm going to do a little a squared plus b squared is a c squared. So here's my a, here's my b. X squared plus b squared is 4 squared. X squared plus b squared is 16. I'm going to subtract the 16. B squared is 16 minus x squared. Therefore, b is the square root of that. And you cannot do anything with that, so don't do anything with that. It is not 4 minus x. It's 16, square root of 16 minus x squared. There's nothing you can do with it. Don't be that kid. Now I want cosecant. I want the cosecant of angle beta, and it is the hypotenuse over the opposite side. So it's 4 over root of 16 minus x to the second. Easy peasy lemon squeezy, right? Right. Find the missing side lengths, 8 and 9. These are about your special rights. So you should have taken, about 3 circle quizzes by now. So you should have this pattern down. The short side is opposite of 30 degrees. The long side, which is x root 3, is opposite of 60 degrees, and the hypotenuse is twice that. And on this one, I gave you the hypotenuse. So you're swinging from the hypotenuse to the short leg. It's all about getting to the short leg, because if you have the short leg, you can get anything else. There's 2 paths. There's only one path from everything else. So x is going to be 50 root 3 over 2, and 50 over 2 is 25, 25 root 3. Y, it says take this short leg and insert a multiplication of root 3. So it's going to be 25 root 3 times a root of 3. If you focus on your like terms, root 3 times root 3 is 3, and 25 times 3 is 75. So there's your missing pieces. Number 9 happens to be a 45, 45, 90. I know that because congruent sides imply congruent angles. And if I do 180 minus the 90 that's given, I'll have 90 degrees. And if I split that in 2 pieces, I get 45s. So this happens to be a 45, 45, 90 using a little bit of logic. And the 45, 45, 90 pattern, as you learned in your sophomore year of high school, is x, x, x root 2. That's it. That's your 45, 45, 90 pattern. So this one's easy. I mean, they're literally marked as congruent. You've got to be some sort of special if you can't figure out x. It's 10 root 6. The theorem says take the short leg, multiply it by a root of 2, and you get the hypotenuse. So this is going to be 10 root 6 times a root of 2. Let's do that off the side somewhere. 10 root 6 times a root of 2. Focus on like pieces, your radicals. And you get 10 roots of 12, which I'll give you some partial for, but you really don't need to be a junior. Like, you need to be shoved right back to your freshman year of high school. This is 10 times the root of 4 times the root of 3, because 4 times 3 is 12. And if you don't know 4 times 3 is 12, again, you're not worthy of being called a junior. Root of 4 is 2, so you have 10 times 2 roots of 3, and you get 20 roots of 3. There's the y. Number sense, kids, learn it. Number 10, an equilateral triangle has an altitude of 6. Find the area of the triangle. So she is equilateral. That means that all three sides are the same. And altitude is the height, and it's 6. Now, what's cool about an equilateral triangle is since all three sides are the same, all angles must be the same, and they're all 60 degrees. When the altitude is drawn in, it bisects that side right there, cutting it into 2 equal parts, and it also bisects that 60-degree angle up top, making it 30 degrees. I swore I changed, and making that the 60. So let's focus on this 30, 60, 90. It has a height of 6. And I would like to figure out the missing side length. So again, I'm going to go to 30, 60, 90. I'll write this one a little bit different. 30 up here. That's supposed to be 60 and 30. Did it backwards up there. Opposite of 30 degrees is x. Opposite of 60 is x root 3. Hypotenuse twice x. I've got this piece. Okay? I need to know this piece. I'm going to work my way backwards. I'm going to divide out the built-in root 3. So this guy is 6 over root of 3. Clean it up by multiplying top and bottom by root 3. And I get 6 root 3 over 3, which is 2 roots of 3. All right, so there's more, because, you know, it's geometry. This guy is 2 roots of 3, which means this piece is 2 roots of 3. So if I think about the whole blasted triangle, it's got a height of 6 and a base of 4 root 3. Now, unless I don't know how to read, I know the area of a triangle is 1/2 base height. 1/2 a base of 4 root 3, height of 6, half of 6 is 3, 3 times 4 is 12, 12 root 3, final answer. Really, really easy. Exactly the kind of problem I enjoyed teaching geometry. Because it's got a lot of little pieces you have to put together. All right. Let me text my wife real quick and I'll get back to it. All right, moving on to 11. Find the diagonal of a square. So I guess the first thing you should probably draw is a square. It has side lengths of 5 root 5. And they're all 5 root 5. And they're all the same because it's a square. Definition of a square is 4 right angles, 4 congruent sides, and they're all 5 root 5. In a perfect world, you would draw in the diagonal and you would realize that this is a 45, 45, 90. Okay? And you'd be like, hey, I know 45, 45, 90 theorem, x root 2. This diagonal is just 5 root 5 times the root of 2, which is 5 roots of 10. Like, that's how easy it is. Or you do a squared plus b squared equals c squared. And you do a whole lot more work because you got 5 roots of 5 all squared plus 5 roots of 5 all squared equal to c squared. And half of you couldn't do this unless you were pushing buttons on a TI-84. This is 25 times 5 plus 25 times 5 equals c squared. Each of these creates 125. This is 250 equals c squared. So c is the root of 250, which is going to be the root of 25 times the root of 10, which is, by God, 5 roots of 10. Notice I ain't using decimals. You're supposed to learn how to do basic stuff by hand, and I ain't using decimals. And you shouldn't be using decimals either unless you're explicitly told to. TV measurements are given based upon the length of their diagonal. A certain TV has a 90-inch diagonal, and the diagonal happens to create two 30, 60, 90s. This would not be the true aperture of a TV, but a diagonal measures 90 inches, And it happens to create two 30, 60, 90s, and you should be able to figure out that this is 30 and that's 60. 30, 60, and it's a rectangle, so it's got 4 right angles. And 30 and 60 make 90. I want to know the lengths and the widths. And by God, I have in front of me a 30, 60, 90. X root 3, 2x. It's as easy as 1, 2 root of 3. Anywho, I'm going to swing from the hypotenuse. I don't know why I labeled this. This would be width or height or whatever, and this would be length. I'm going to swing from the hypotenuse to the short side by cutting in half. See how the 2 disappears, and I get 45. And I'm going to swing over here to the length by inserting a root of 3. 45 roots of 3. 13, I like the way they worded this question might be triggering. An extremely depressed individual who is extremely good at math, standing at the top of a building, estimates that there is a 43-degree angle of depression to a car parked approximately 500 feet away from the building. To the nearest foot, how far a drop to the life net the firefighters have set up. Now, this guy really likes math, so if you shout out the distance, he ain't going to do it. If you miss it, you have a jumper. So, let's make sure we get this right. All right, so first off, we got some dude standing on top of a building. This is my building. I guess this will make more sense. Put some windows in there. There's a car over here. It's going to be a bad looking car. And it's 500 feet from the car to the building. And old boy is up here. There they are. They've got a life net set up at the bottom, to catch the person. And there's a fire truck there and all sorts of stuff. And I'm sure the TV stations are there too, but whatever. I want to know how tall the building is. Now, this dude who's good at math has decided that there is a 43-degree angle of depression. And angles of depression are formed with the horizon. And they are also congruent to angles of elevation. So I'm going to take my 43 and I'm going to put it right there. And then I'm just going to do a little bit of SOHCAHTOA. I notice that this X is the opposite side, and something that gets a lot of kids is adjacent. Adjacent means you touch the angle, but you ain't the hypotenuse, okay? So I have the O and I have the A. I have the tangent ratio. The tangent of 43 degrees must equal X over 500. The opposite of division has always been multiplication. It always will be. And here's my answer. 500 tangents of 43. So calculator needs to be put in degree mode. It is 500. By the way, check that on quiz day because I'll reset your calculators and by default they're in radians. Nearest foot, 466 foot. So X is about 466 foot. By the way, a story on a modern building, because they put a lot of stuff in between floors, is usually about 10 feet. So this thing is about 46 stories tall. Pretty tall building. Bearings are formed with the north-south axis. A flight communications tower spots an aeroplane at a bearing of north by 54 degrees west. So let's go ahead and put a little communications tower here. We'll just call it point C. And they have spotted an airplane. Looks more like a bird across at a bearing of north. Oops, mine's backwards. We have some tower at the origin, and they have spotted an airplane at north by 54 degrees west. Notice I put that angle outside of the triangle, okay? That's 54 degrees west. And there's an airplane. A second tower has spotted this plane 50 miles due north of their location. So there's a second tower, Tower 2, and that airplane is 50 miles straight north. I want to know how far that this airplane is from the first tower. So I actually want to know this leg X, and it's not 54 degrees. The 54-degree angle is actually down here. And it's also not in your triangle of interest. This angle right here is an angle that matters. This is understood to be 90 because that plane was due north. That angle's 90 minus 54, which is, I believe, 36 degrees. So let's do a redraw so it's not so cluttered. We've got 36 degrees, we have 50 miles, and I want to know this piece. What do I have? I have the opposite side, and I have the hypotenuse. So I cycle through SOHCAHTOA, that's what this is about, SOHCAHTOA, and I decide I'm S-O-H. The sine of 36 degrees must equal 50 over x, and this is a two-stepper from here. First step, x both sides. Cancellation on the right-hand side. Now I have x sines of 36, it's pronounced sine, it's not pronounced sin. Is 50. Next step is isolate the x through division. And the last step is to push buttons. Again, calculator in degree mode, check it. Once you set it once, you don't have to do it again. And I get about 85 miles. It's actually 8506 or something like that. All right, moving on. Almost done with this sheet. I think this is the last one. It is. The tree shadow measures 98 feet long with a measured angle of elevation of 58 degrees to the top of the tree. How tall is said tree? So there is a big giant tree. Here's my ugly tree. From the top of the tree to the ground, we have an angle of elevation of 58 degrees. The shadow which lies on the ground is 98 feet, okay? I want to know how tall the blasted tree is. This is probably going to be the tangent ratio. Most of the tree problems are. There we go, x. X is the opposite side. It is opposite of the angle. 98 is the adjacent side. Now, I taught trig for years, and I do it every single year. When it comes to SOHCAHTOA, the issue kids have is picking out the adjacent side. It is always the issue. I don't know that it's being caught on if that's your issue, but I've been teaching trig for 15 years now. And every time a kid gets to me, the issue is always what side is adjacent. Now, if you're that moron who can't figure out the hypotenuse, there just wasn't any hope for you. You haven't paid attention in 15 years of schooling. I mean, they start talking about the hypotenuse around 3rd, 4th grade. It's not a hard concept. But anyways, I have the O and I have the A, and by God, I can spell a word that doesn't exist called SOHCAHTOA, an acronym, sorry, and it must be the TOA. So the tangent of 58 degrees must equal opposite over adjacent, x over 98. I 98 both sides, and I have an answer as soon as I'm willing to push buttons in a TI-84. And by the way, I might write it so you don't have to push buttons in a TI-84, because that technically is the answer. There's nothing wrong with it. The tree is roughly 157 foot tall. I'm just going to round the nearest foot because it's kind of a real world problem. Nobody really cares the exact inches and stuff like that. It's about 157 foot tall. Tall tree. It really is. And there you go. There's your homework assignment, and it is a homework assignment. And if you've done all your worksheets, you didn't have to do any of this. But anyways, enjoy.